Good morning, students. Now, from last 2-3 classes, we were talking about the square numbers, the consecutive square numbers, the patterns, all this we spoke. Now the square roots. Okay. Now, what are square roots? Before getting into the square roots, I just wanted to tell you a few concepts of other operations. For example, now whenever we do an addition, let's say addition, right? Addition. Okay. What is the inverse operation of an addition? Inverse means the other way. The reverse. Inverse is nothing but inverse operation. Inverse operation. The reverse operation. Okay. For example, if I do 6 plus 4 is equal to 10. Okay. With the 10, I want the answer 6 again. So I will do minus 4. I will get 6. Understood? The addition inverse operation is subtraction. Similarly, multiplication inverse operation is division. Like that. The square's inverse operation is square root. Okay? It is nothing but we are just getting the core value of these squares. Now, for example, I know that 16 is a square of some number. How do we find that? 16 is a square of which number? 4 square. But how do we find this number? Okay, that is to find this number we have different options, different methods. Now, what do you call it when you find the numbers? It is called as square roots. Square roots, and the symbol of this is this one. If I have to find this number, I have to put this number here, and then the answer will be 4. Square root of 16 is 4. The reverse operation is 4 square is equal to 16. 4 square is equal to 16. Root of 16 is equal to 4. Okay? Square root is nothing but an inverse operation of a square numbers to get the perfect number. Now in this, to find, there are different ways to find the square root. Okay? Now for example, if I have 16, 16 we already know it is 4. Root of 16 is 4. But how do we get to know if we do not know? What we can do here is there's a method called repeated subtraction. Okay? Repeated subtraction. How do we do this? Okay? Now repeated subtraction is done by subtracting the odd numbers. Now what are the odd numbers? 1, 3, 5, 7, 9, 11. Now if I have to find a square root of 16, take the 16 number. Okay? First step, 16 minus 1. How to get? Second, take the same 15 minus second number, which is 12. Good. Take the 12 minus 5. 7. Take 7, which is the next number? 7. You have to stop once when you get the zero. Now, how many steps we have taken? 1, 2, 3, 4. Therefore, root of 16 is 4. How do we verify this? You can just do square. 4 square is 16. This is the method wherein we find the square root of any number. This method is called as repeated subtraction. We can do this for any number. If you take a big number, it takes a long time. Now if I take 81, okay, how do we start with? 81 minus 1 is equal to 80. 80 minus 3 is 77. 77 minus 5 is 72. 72 minus 7 is 65. 65 minus 9 is 56. Correct? Now 56 minus 11, how much? 45. 45 minus 30 is 32. 32 minus 15 is 17. 17 minus 17 is 0. How many steps we took here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So root of 80 minus. This is how we do the rooting. Square root of any number using a repeated subtraction. Let's see what do we have in the next. Now if you have a big number, say for example 6400, can I do a repeated subtraction for this? Because it will take a complete board and it will be a huge steps. So what we can do here is, there is one more method for this. The method is prime factorization. Prime factorization method. Now the prime factorization method. Now in this method, what happens is, you know what is prime factorization, right? You are factorizing the number using prime factors, prime numbers. 6400. Start with this. We should always start with 2. It's an even number. 23200, 21600, 2800, 2400, 200, 200, 250, 225, 5, 5 ones. Write this number in order. Okay? How many twos we have? 1, 2, 3, 4, 5, 6, 7, 8, and 2 5s. 1, 2, 3, 4, 5, 6, 7, 8 into 5 into 5. Now we are finding a square. Square is nothing but, right? So that means group it. Group it to 2 numbers. And in each, take one number. Multiply it all. Whatever the answer you get is root of 2 twos are 4, 4 twos are 8, 8 twos are 16, 16 fives are 18. So this is the answer. This is called prime factorization method. Okay? And in this, let's see what we have in the exercise 5.3. What could be the possible ones digit? That means the unit digit of 9801. First name. See, in squaring and rooting, the unit digit will always be same. 9801. Unit. When you multiply with 1, you will always end up with 1. So this is the number. For all, now 9856. 9856. In this, we get the unit digits, right? So if you multiply 6 into 6, it's always 36. In this, without any kind of a calculation, find the numbers which surely not a perfect square. Again, 153. You remember, right? 2, 3, 5, 7. The numbers ending with 2, 3, 5, 7 are always not a perfect square. Remember that. Next is Third main, find the roots of 100 and 169 by repeated subtraction. We have already done. I want you to try that. And the fourth main, find the square roots using prime factorization method, which we just did now. So 1 to 4 mains. I don't think you should have any problems. I won't